Hello, welcome to my channel. I am Ameya and we are discussing about control systems, in which we are about to discuss a topic called type of control systems. Now, the open loop transfer function of a unity feedback system can be represented in two forms, and depending upon those two forms, those systems can be classified into type 0 system, type 1 system and type 2 system. Okay, so let us discuss how this standard form works, and then let us discuss how these type of systems can be classified. So the open loop transfer function can be represented in two forms. The first form is called time constant form, in which you will find the tau or time constant t is used in terms of g of s. So if it is, just a second, I will just increase the thickness and erase this. Yeah. So g of s can be given by k, and in the numerator 1 plus tz1s, 1 plus tz2s, and so on, upon s raised to n into bracket 1 plus tp1s and 1 plus tp2s, and so on. Here, this is called time constant form, where the coefficients are associated with the s term. Okay, so all the coefficients which are associated with s term, and there is a unit in constant term, one in constant term, that means this is the representation in time constant form. Now the second type of form is called pole zero form, and we will use it very commonly in our coming videos and also solving for various methods. It is k into s plus z1, s plus z2, and so on, and in denominator you will get s raised to n, s plus p1, s plus p2, and so on. So this is called the pole zero form, in which in the numerator you will get s and the constant term separate, and these are called zeros of your system, and in the denominator similarly you will get s terms which are called poles. Okay, so this representation is called pole zero form. You will find most of the representations in pole zero form. Okay, so now depending upon these two constant forms, you will get type 0 system, type 1 system, and type 2 system. Now let us understand how these systems are getting defined. These systems are getting defined on the function called s raised to n. Okay, from the both forms, this depends on s raised to n. If n is equal to 0, that means no integral term in denominator, then that is called type 0 system. Okay, then if n is equal to 1, that is 1s in denominator, that will give you the type 1 system. And similarly, if n is equal to 2, that is 2s or s square in denominator, that will give you type 2 system. Now you can easily identify various types of system. Let us take an example how to identify those types of system. Let us say we have g of s, h of s is equal to k into s plus 3 upon s square into s plus 2, s plus 5. First, we can identify type. This is pole 0 type. and then you can look for the term of S in the denominator, and if there is 2 in there, that means it is type 2 system. So you can say this is type 2 system. Okay, so let us take one more example. G of S H of S is equal to S plus 2 upon S minus 3 S plus 3. Okay, so in this this is again a pole zero form. The only problem is there is no term of S, that means there is S raised to 0, and S raised to 0 means this is type 0 system. Okay, it is as simple as that. You can easily identify type 0, type 1, type 2 system depending upon the value of S raised to n, which is in denominator of your pole zero form or time constant form. So this is what I want to discuss in this video, that types of control systems and how you can identify those various types. We will be using these types in coming videos and coming various methods which we are trying to understand for a control system. If you like this content, do share my channel with your friends. Do subscribe my channel for latest update, and also check the playlists which are available on my channel about the control system, mechanical measurements and industrial automation. Thank you for joining.